So our last section for the chapter and our last section for the whole year is the midpoint formula. This is another formula that you're going to have to memorize. And basically what you're doing is you're finding the exact halfway point between 2 points, the midpoint. In geometry, you spend a lot of time dealing with midpoints, either on a coordinate plane like this or the midpoint of like a line segment just in random space, like the midpoint of a segment on a triangle or something like that. So midpoint does come into play a lot in geometry class, as does everything that we've done in this entire chapter. That's why it's so important that you do well on this one so you can hit the ground running next year. The midpoint of a segment with endpoints at x1, y1 and x2, y2 is given by this equation right here. So if I have 2 numbers that I plug in here, like 5 plus 7, and I divide those 2 numbers by 2. So I'm taking 2 numbers and I'm adding them together and I'm dividing by 2. What is that? What am I doing? What are you doing when you take 2 things and you add them together and then you divide by 2? What's that called? Yeah, it's the average. Really all this is the average of the x coordinates, comma, the average of the y coordinates. The midpoint formula is super easy if you can remember that. You're just averaging the x coordinates, average the y coordinates, and you're done. So you just have to add the 2 x coordinates together, divide by 2, add the 2 y coordinates together, divide by 2, and that's it. Okay? Now, let me show you on the graph here. If for point A, which is sitting right here, if I draw a little dotted line over, that would give me my y coordinate. If I draw a little dotted line down, that would give me my x coordinate. So that could be x1 and y1. If I do the same thing, if I draw a little dotted line down from point B, that could be my x2. And if I draw a little dotted line all the way over, that would be my y2. Hang on. The midpoint is going to be halfway between the x coordinates, so halfway between this x1 and x2, and halfway between this y1 and y2. So that's like maybe right here. That would be the average, x1 plus x2 divided by 2, right there. And then over here, the average of my y coordinates, y1 plus y2 divided by 2, and that gives me my midpoint, which is halfway along that segment, no matter what that segment looks like, no matter how long it is, no matter how it's oriented. It could be horizontal, it could be vertical, it could look like this, it could be going up from left to right. It doesn't matter. This formula works for every single 2 points on that plane. It's very easy to do. All right, so once again, I'm giving you the grid. We'll put these dots down. You actually don't have to put the points down. It's going to be easier to just use the formula, but just so that we see, let's plot these points. We have -1, -2, which is right here, and we have +3, -4, which is right here. So we want to find the midpoint between those 2 points, halfway between. If I drew a segment in here, it kind of looks like that midpoint might be right in here. So maybe +1, -3, I don't know for sure. But it might be right in that area right there. So we're just going to use the midpoint formula, which I'll rewrite here because it's the first time we've seen it. Again, you have to have this one memorized. Parentheses, because it's an ordered pair, the midpoint is an ordered pair, so it's parentheses x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. Or you could say x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. It doesn't matter. When you're adding, you can add in either order. So we have m equals, add the x coordinates together, so that would be 3 plus -1 and divide by 2, comma, add the y coordinates together and you have -4 plus -2 divided by 2. And then you just simplify it down. M equals parentheses 3 plus -1 is 2. 2 divided by 2 is +1, comma, -4 plus -2 is -6. -6 divided by 2 is -3. So your ordered pair for your midpoint is 1, comma, -3, right there. So from the graph, it did look like it was 1, comma, -3. And from the math, it turned out that it actually was 1, comma, -3. But that's how you use the midpoint formula. It's very easy to do. Find the coordinates of the midpoint of the segment with the endpoints at 0, 0, and 5, 6. So let's put the graph on here first. The 0, 0 is here, and then 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Right there. We're trying to find the midpoint for the midpoint of the segment that connects those two dots. So what should we do? M equals, open parentheses. So add your two x coordinates together, and that would be 5 plus 0 divided by 2, comma. Add the y coordinates together, 6 plus 0 divided by 2. So when we simplify that, we have m equals, parentheses, 5 halves, comma, 3. So 5 halves is like 2.5. So here's 2.5. And then 3, it does look like, even though I just randomly drew that segment in there, it does kind of look like it should be about 5 halves, comma, 3. So we probably got the right answer. So for this one, what should I write? M, capital M equals, it's capital M, not a little m. Little m represents what? Slope, yeah. So capital M is midpoint. And we have parentheses, what? The x coordinates, so I could write them negative 4 plus 5 over 2, comma, the y coordinates. 6 plus negative 3 over 2, or you could write 6 minus 3 over 2, that's fine too. Negative 4 plus 5 is 1, so we get 1 half, comma, 6 plus negative 3 is 3, so 3 halves. 1 half, comma, 3 halves. All right, let's put the graph on there just to see if it actually looks like 1 half, comma, 3 halves. 1 half would be right here. 3 halves is like 1.5, so we're looking for a midpoint that's right about there. All right, let's put the segment on there and see what happens. Negative 4, 6. So negative 4 is over here, and then 6 is all the way up here. I did go negative. Then 5, negative 3. 1, 2, 3, 4, 5, and then negative 3. So they do kind of look like they line up. Let me use a ruler because that's kind of a long one and I don't want to screw this up. There you go. Pretty close, right? My segment is probably off by a little bit, but that's definitely going to be the midpoint. It does look like that piece right there is the same length as that piece right there. So it should be about exactly halfway between the two. All right. So these last two problems that we're going to do, take what we did in the last section and this section and put them together in one nice problem. So we have two ordered pairs here, which is going to create a segment for us. We have 5, comma 4. Here's 5 and then 4. And then negative 2, negative 4 is right there. So we're going to have this segment. We want to know how long is the segment and where is the midpoint of the segment. So we need to do two separate problems on this one. It's the same problem, but there's two parts. So the length is going to use what formula? Probably not the quadratic formula. The distance formula. And the midpoint is going to use the midpoint formula. So it's really just two kind of easy problems from the last two sections. So first of all, let's do the length. What do? D equals square root . Right, this one is x2 minus x1 squared. Okay, now the toughest part between these two sections is remembering which one has plus and which one has minus. The midpoint formula looks like ordered pair, and it's the average. So this one is the one that you're adding together. x1 plus x2 over 2, y1 plus y2 over 2. Remember last time I wrote it x2 plus x1. This time I'm writing it x1 plus x2. As long as you're adding them together, you can add in any order you want, so this is legal to write. Notice the difference between the two. This one has square root and a bunch of squares. This one is an ordered pair, and you're averaging the x's and the y's. Yes, true. Okay, so let's do distance first. Let's substitute in what we know. D equals square root, what? x2 minus x1, so negative 2 minus 5 squared plus parentheses negative 4 minus 4. Negative 4 minus 4. This one is the minus one. And then we square that. So now we have d equals square root, what? Negative 7 squared is 49 plus negative 4 minus 4 is negative 8, and we square that and we get 64. So we have 49 plus 64. If we add those together, we get d equals square root 113. Is there a perfect square that goes into that? How do you know? Well, 113 isn't in the list, but is there a perfect square that goes into 113? No? No. 2 doesn't go into it, 3 doesn't go into it, 4 definitely won't, 5 won't, 6 no, maybe 7? No? Okay, if 7 doesn't go into it, then 49 doesn't go into it. 8 doesn't. Maybe 9? No? Okay, 16 no, 25 no, 36 no, 49 doesn't. Is there one? No. So the answer is the square root of 113. That's what you need to do. Don't just assume that it doesn't simplify. Always check those perfect squares to see if one of them will go in. If it's an odd number, you really only need to check the odd perfect squares. So 9, 25, 49, 81, and so on. All right, so that's the first part of the problem. Let's substitute in what we know for the midpoint so we can get the second part of the problem. Capital M equals, parentheses, 5 plus, and then negative 2 divided by 2, comma, 4 plus negative 4 divided by 2. So M equals, parentheses, 3/2, comma, 0. Yeah, 4 plus negative 4 is 0. 0 divided by 2 is 0. So there's your midpoint. And if I look at the graph, 3/2 would be about 1.5, and then comma 0. That does look like the midpoint. And I even drew that one in there by hand. So that's pretty good. The distance, square root of 113. Again, you can make the Pythagorean theorem if you're given the graph. We have a right triangle now. We have 1, 2, 3, 4, 5, 6, 7 units this way. 1, 2, 3, 4, 5, 6, 7, 8 units this way. So to do the Pythagorean theorem, I'll have c squared equals 7 squared plus 8 squared. C squared equals 49 plus 64. Square root both sides, and you have c equals the square root of 113. It's the same thing. 10.63. Leave it as an exact answer unless you're asked specifically to give the decimal approximation. Okay. This one's for you. Same type of problem, just different points. Find the length and the midpoint of the segment that is made by those two ordered. All right, distance formula first. What do I write? So let's go straight into actually writing that down. We have something being squared plus something being squared. x2 is 2 minus x1, which is 1. All right, so we have d equals square root 1 squared, which is 1, and then plus negative 4 minus 6 is negative 10. Negative 10 squared is 100. So we have d equals the square root of 101. Can that be reduced? No. So that's the answer. Put a box around that. We'll move on to the midpoint. M equals parentheses. What are we looking for here? Which is the, well, yeah, that's what we're doing, but what is x1 plus x2 over 2? What are we actually doing there? Averaging the x coordinates. So we have what? 1 plus 2 divided by 2, comma, negative 4 plus 6 divided by 2. So m equals parentheses 3 halves, comma, 2 halves, which reduces to 1. There's your answer. Let's double check this. We have 1, 6, which is right here, and 2, negative 4, which is right here. So we have that segment. Length of square root of 101, so that's pretty much a length of 10, like 10.0 something. And then 3 halves, comma 1, looks about right. So I'd be willing to bet that's the right answer. Okay, what does the packet say the homework assignment is? 1 through 18? Okay. There you go. You are officially done with Algebra 1. We still need to do the homework.